Oh, how are you doing?
I'm great, Simon. How are you?
Not too bad, thank you. Oh yeah, I recognize the shirt. Now I know where I recognized you from. So, you're in Tel Aviv?
Yeah, I'm based in Tel Aviv.
It's a
Uh,
little bit tough to hear you. I wonder if you can move the mic a little bit closer.
yeah, is it okay now?
That's a little bit better, yeah. So maybe I'll probably put the volume up as well. Maybe it's me. Yeah, thank you very much for joining. Or you're a development team lead at SNCC, right?
Mm-hmm.
And what
Yeah.
team do you work on?
So I'm celebrating 2 years today. So
Really,
yeah,
congratulations, happy
great.
anniversary.
Yeah, thank you.
Excellent. And the talk you're giving today is hack my misconfigured Kubernetes.
Mm-hmm.
Oh,
Exactly.
don't tell me people are misconfiguring Kubernetes. I don't believe it. How big a
Right.
problem is this?
So I think it's a big problem. I think that it's still, we'll talk about it, but it's still kind of a gap of education. People are still not familiar too much with the environment and the risks that can be as part of it. So yeah, this is what we're going to talk about.
Awesome. Sounds like a good session, all, and I'll pass over to you as I know it's a short one, these sessions, so I don't want to take up too much of your time. So, over to you.
Wonderful. So hopefully you can see my screen right now. It's a huge purple slide with a cute dog on it. So again, my name is Kamara. As we like software team lead at Sneak. Sneak again is a developer first security company that helps organization to use open source components. And before Snake, I worked as a security engineer in the government of Israel. And yeah, this is me in the picture 1 year ago in an amazing trip in New Zealand. This is me those days doing Zoom sessions all day long. So in this talk, I'm going to talk about potential attack vectors in the cloud environment. We'll talk about the complexity in this world, what's a little bit different in this world. And then we do kind of a drill down and talk about Kubernetes pods configurations. More specifically, we're going to talk about security context and resource limitations. We're going to talk about the usage and how useful are they, but also talk about the security risks that are part of those configurations. So I think that the main question is how well configured is your cloud environment? And I wanted to start with a good example. I probably will all familiar with the hack of Capital One. So basically, it was a huge one. I think it affected around like 1 million users only in the US and around like $1 million in costs. So it's a great example for two things. The first one is misconfiguration because Capital One actually admitted that there was a problem in the configuration. And the second part was the amount of potential security pitfalls that we should all be aware of. So the actual steps in the hack itself were like several steps into several areas. So the first one was a misconfigured load balancer. The second one is what was a vulnerable app with an SSRF vulnerability. And the third thing was an over-permissive S3 bucket. So all of those together basically help the attacker doing the hacker doing the attack. So I would like us to talk a little bit about the ownerships of developers those days in the cloud environment. So we have the source code of the application itself, right? This is an example for a Python app I just built. So I need to make sure that the application by itself is secure. We have the third-party dependencies of the application. So this is the requirements.txt file for my Python app. And I need to make sure all of the dependencies are secured. And then we are wrapping the application inside the Docker file. So we have like the base image and we have all of the components of the base image. And we have all of the OS packages that we're installing as part of the Docker image. So we need to make sure they are secured as well. And then we have like all of the platform itself. So infrastructure as code files like Terraforms, also a potential risk, a security risk. And last but not least, the thing we're going to talk about today is the Kubernetes files. And this is like an example for deployment file. Again, like a place to make sure that there are no mistakes in. So yeah, too many things to worry about. And again, today we're going to talk about Kubernetes security. So just two quotes I wanted to start with. The first one is about the fact that security of Kubernetes is not that simple. And someone might say it's a bit complicated. And the second one is that it's up to the DevOps team and the DevSecOps teams to implement those configuration and enforce those. And I will add that, in my opinion, it's also part of the developers to do these jobs as well. So now let's talk about specific configuration as part of Kubernetes. The first one will be security context. So for those of you who are not familiar with, security context basically defines privilege and access control setting for the pod or the container itself. So this is how it looks like. This is my my pod object. And more specifically, this is the security context area. And here we can see like two different attributes that we're going to talk about today, privilege and capabilities. So the first one is, again, privileged pods. So what exactly are privileged pods? Privileged pods basically let the containers access and use the host resources. And basically think about scenarios where you need to access the graphic card or the network stack. For all of those, you actually need to use the host's resources. And the security risk is quite trivial here. So basically, processes in privileged containers mean that exactly root processes on the host itself. In other words, if we have an attacker on this pod, they can basically do anything they want. So the solution in this case is quite simple. Do not set privilege setting to true. There are some cases, I got to say, where you can use this option and use actually privileged containers, but you need to be aware of the consequences. So let's start with an example with the demo. So in this demo, we'll have two different apps. The first one will be an isolated app that basically writes files to the disk, like a secret file with credit cards and with details of credit cards. The second app is basically a vulnerable app, and this vulnerable app contains RCE, remote code execution vulnerability in the app itself, and also it's also a privileged pod, and this is the problem. So this is our node, and basically the two apps running on the same node. It basically means that both of them are using the same Docker engine, and also the Docker layers are stored on the same local storage. So in other words, an attacker can basically access all of the files of the payment. An attacker with an access to the vulnerable pod can basically access the files of the payment application. So now let's go into the demo. Share my screen. So yeah. So what you can see here is like, can you see my terminal? Yeah. So in this example, we'll see like this two applications. So we have like the web application with a privileged true, and I'm basically using Minikube to run everything, so we can see like the deployments that we have. Just a second. Minikube froze. Yeah. So we can see the deployments that we have, like those two deployments, and we have the pods, and we have an ingress to access this application. And this is basically our application. So we have two parts here. The first one is more like just a place to post feedbacks and to upload photos. The second one is to support our app. So let's start by supporting our app. So I'm gonna donate like $1 using Simon credit card. And yeah, we donated $1. And now let's see what we can do as an hacker on this website. So the first thing I'm going to do is trying to upload something different than an image, and I'm actually going to upload a shell script. And this shell script, this is the shell script. Basically, this shell script is the example for the RCE inside the app. So once I uploaded the shell script into the application, I can now access it using the app and run commands on the pod itself. So now, when we uploaded the shell script, we can now access it using curl commands. So I'm taking the IP of the server. So I'm going to switch all of the IPs with this one. Now I need the name of the file itself. So when I inspect this page, I'm going to click on that. This is the name of the file itself. So I'm going to replace it in my template. So now basically what we have are curl commands that we can access as an attacker to the pods and try to get some information. So the first thing we're going to do is just to make sure that we are actually running on the same pods. So we're going to run a uname command. And this is like the results. So this is the name of the machine that we're running on. Just for validation, we're going to do the same thing from the pod itself. So we're going to exec into the pod itself. This is the name of the pod. And we're going to run the uname command again. And you can see that the output, the result, is exactly the same thing. So next thing we're going to do as an hacker, we're going to create a new dir under temp host. And the next thing we're going to do is to do a list, run a list command, and to check how many files do we have in this dir. So right now we have nothing. We have 0 files in this dir. So next thing we're going to do is to mount, and this is like the interesting part, we can mount the host file system into the dir we just created. So this is the command we are running. We're running mount of devda1 into temp host. So we run this command, and hopefully it's worked. Let's see if it's actually worked. So let's check the files under the host dir. So before we had nothing, like when we run the ls command, but now we actually can see some directories after we run the mount command. Now, when we actually can access the host's file system, we can look for all of the files named cards.json. And let's assume that the sophisticated hacker already investigated the network and they realized like the name of the interesting files. So now we're going to run a find command. Now we have like the name of the file. And just want to say that those two, like this path is basically part of the Docker layers. You see, it's like where the Docker, basically the Docker engine keeps all of the layers under the overlay to directory. And now we are accessing the Docker layers themselves. So I'm going to take this one. And I'm going to cut the content of this file. Okay, so we have two different files because each one of them is a different layer. So I'm going to take the second one. And now we can see the credit card from the second pod. Okay, so this is actually the problem, and now let's see how we can solve it. So let's turn this privilege into false. You can also drop it. Let's turn it into false. And now we're gonna clean all of our environment. I have a nice script for creating the environment all over again. What you can see here is that the new pods are being created. And now let's try to do exactly the same thing. So I'm gonna upload this PHP script again, and I'm going to use exactly the same command that I just used before. So the first one will be to create a temp dir. I'm going to check the content of the temp dir. I expected to see nothing, and now I'm going to run the mount command. Now I expect to see something, but I still see no results. And the reason for that is because we changed the privilege into false. So if we want to try to run this command inside the pod itself, let's exec into the pod itself. Now let's run the mount command inside the pod itself. And now there's an attacker. And now we see the permission denied error. Cool. So let's go back to the presentation. Cool. So we talked about privileged pod. Next thing for us is to talk about root containers. So when exactly do we need root containers? So root containers are useful for different type of actions that we want to do with more permissions inside as part of our application or inside our pods. For example, installing packages or accessing specific files in the on the disk, network operations, or mounting volumes. All of this stuff. For all this stuff, we actually need to root users. And I think that the important part here is that we can easily forget or kind of miss the fact that our images can run as root. So in this Docker file, in this simple Docker file, you can see that I'm just using the base image PHP CLI, and then basically I'm doing nothing related to the user, but it's the result of this Docker file. When we will actually build it, the result will be an image with a root user. So from the security perspective, again, it's kind of trivial, but root services make it easier for the attacker to take privileged actions. And again, like we mentioned before, accessing files, exploring the network, accessing other containers. So let's talk a little bit about the solutions. The first one can be Linux capabilities. So it's another option under the security context. And basically, Linux capabilities are an option to grant specific permissions to your application, to your service, and it's basically help you to prevent granting a full root access for application. So the first recommendation is to start by dropping all of the capabilities of your application and then gradually add those capabilities you actually need, your application actually needs. So let's try it. So this is my Docker file. I'm using like a PHP, and this is my deployment. So you can see that I'm not running a privileged pod. And now what we're going to try to do is to run inside the pod itself and to run Nmap command. Nmap is basically kind of a tool. It's a free tool for network scanning, and it's commonly used by attackers to discover hosts and services and computers in the network. So you can see that in the terminal, I basically ran the nmap command, and then the nmap command actually found like the payment service in the network. So now I can ping this payment service, and if, for example, this payment service has a vulnerability inside it, maybe I can access it. Like using the network. So now let's try to solve it. And what we're going to do right now is to drop all the capabilities of this pod. So we basically add drop all. I'm going to clean up my environment, and then I'm going to build everything again. And you can see that new pods are being created right now. So we have new pods running, and we're going to exec into one of those, into our web deployment pod. And we're going to try to do exactly the same thing. We're going to find the IP of our pod, and we're going to run the nmap command again. So exactly the same thing as before. But now we have failed to open the network device. And if we're going to try to do ping as well, we also got operational permitted. So the reason for that is that basically Nmap sends and receives raw packets. So it's need to access the raw network socket of the pod. And this is why Nmap and also ping commands must run as a root. So basically we just blocked it. And now let's go to the second option. And the second option is the option of run is non-root. And I guess you can understand from the name, it basically means that we can make sure, or kubelet won't start the container if it runs as a root. So the simple recommendation is just turn it on if you don't need a root container. Let's see this example. So we're going to use exactly the same setup again. Let's remove the capabilities option and let's turn on the run is non-root option. So we're going to clean up the environment again and run the build option. And what you can see right now, that one of the web deployments failed with create container config error. And when we will try to run a describe command of this container, we will see the error. And the error is, just a second, and the error is container as run is non-root and image will run as root. So basically, we managed to block this root container. Great. So next thing and last thing we're going to talk about are resource limitation. Basically, we're talking about different type of security issues. I think resource limitation is a great example for like the bad behavior of defaults in Kubernetes config world. And one thing we should one thing we should definitely be aware of, like the defaults. So two resources that we're talking about, like CPU and memory. And basically, by default, pods are running with unbounded limits. So it means that a single pod can consume all the memory and all the CPU that are available on the node itself. And it also means that Kubernetes might kill the application or other application in the same node when we will reach those limits. So again, defaults are never good, and we should be aware of them. And the best thing to do in this case is to manually assign those resources according to your application. So the first scenario of the CPU, I think it's the simple case, because basically when your application hits the CPU limits, there is a throttling mechanism that will prevent the application from taking all the resource, all the CPU resource. And in this case, basically Kubernetes will not terminate your applications, but the worst case scenario will be that it will only affect the performance. So everything will run slower, but like all the application will still be alive. A different scenario is with memory, because memory, you cannot compress memory, right? And so if we will reach the memory limit, Kubernetes will start killing our pods. So the worst case scenario from like a security perspective is kind of a DOS attack, denial of service attack, where attackers can actually block legitimate users from accessing our application. And I think that even more, like the worse than the worst case scenario, is a DOS attack that like we will block other applications in the same node, that are running on the same node. And this is like the demo that we're going to see right now. Let me share my. Okay. So in this demo, we can see two different applications. The first one is like an innocent app where we can see the free available memory on this application. And the second one is the vulnerable app where attackers can actually consume memory, for example, by a DOS attack. So the first thing we're going to do is try to allocate megabytes from the vulnerable app. And what you can see right now is that we see a drop in the amount of free available megabytes in the innocent app. Let's do it again. Let's try to allocate 200 megabytes. And you can see a drop in the, not right now, let's try it again. Yeah, you can see that there is a drop in the available megabytes. Okay, so now what we can do is try to turn on the resource limitation. I'm going to limit the memory to 50 megabytes. Try to clean our environment. Let's try to build everything again. So you can see that I got 2 new deployments, app1 and app2. Now, let's make sure that everything is running. Yeah. And now let's try to allocate again the same 200 megabytes. Well, we just failed. And basically we failed because Kubernetes blocked us from allocating all of those megabytes. And basically, let's just try to allocate 10 megabytes. We can see that it's actually working. Okay, so I'm allocating 10 megabytes, but I cannot allocate like more than 50. Go back to my slides. So yeah, basically in this demo, we basically explain why we need to put proper boundaries to our application, and we need to make sure that they don't consume too much resources that might affect like other applications on the same node. So let's talk about some conclusions. What did we talk about? We talked about the ownership of the developers in the cloud environments and the fact that it's getting bigger and bigger, and also about the fact that Kubernetes is part of it, right? Kubernetes and Kubernetes security is part of your service, is part of your application. We talked about security context, and we talked about a different type of security risk, of like default security risk, like resource limitation. So Kubernetes security is hard, but it's definitely doable. And I think that developers should be familiar with Kubernetes risks as inseparable part of the application. But at the same time, we need to help them, right? We need to use the proper tools. So like everything will be easier as part of the development process, but we also need to help them to get familiar with those risks. And again, it's all about the education. And another concept that I think that kind of connected really good with the previous slide is that we need to help the developers by using those tools and adding them to the pipeline. So automatically catching all of those security issues as soon as possible during the development process will basically help us remove those issues in production and fix them as soon as possible. So what didn't we talk about? So other important type of security components as part of the Kubernetes config, like RBAC, role-based access control, the network policy, other interesting features under the security context. So please make sure you're familiar with those, and at least, yeah, like you know what's the proper behavior in your environment. We also, because we're lack of time, we also skipped the tools you can use, other tools you can use to help you as part of this process. So if I manage to convince you that Kubernetes security is important, so please check out this list. The last one in this list is the product that my team is working on at the moment. So again, just take a look on all of them. So thank you very much. Thank you for your time. I really hope you enjoy. You can find me on Twitter. You can find me on LinkedIn. And that's it.
Wonderful. Thank you very much. Got a quick minute. There's just checking for questions. If anyone has any questions, please do ping them through. Would you say there is a in terms of one of the biggest problems with these kind of vulnerabilities and issues in configuration? Do you think it's an insecure default issue, or do you think it's an education for users issue?
So I think it's both of them. Like obviously there is a problem of the defaults, and like you need to make sure that like you're not using any defaults, or if the defaults are appropriate to your own environment. But I think that it's also the problem of the education, because if people are not familiar, like if the developers are not familiar with those issues at all, then like they will stay with the part of the application, but they will not stay with they will not talk about the security risks in the environment itself, like in Kubernetes itself. So it's both of them.
Awesome. Thank you very much, Or. Really appreciate your time on the conference. Thank you very much for your support.
Wonderful, thank you.
And yeah, we'll jump into a 15-minute coffee break, and then we will be in the final stretch, the last hour of the conference. So thank you to Or and thank you to Snick for your sponsorship and hosting, and see you all soon.